A little bit of Science 10 review here. We're going to look at significant figures or significant digits. They really mean the exact same thing, and I use the words absolutely interchangeably. So stay with me on that. So a few things to remember is that leading zeros are insignificant or do not count towards our significant digit count. Leading zeros are any zeros before the number. So these zeros do not count. We don't count them in our significant digit count. Any number afterwards that is actually a number from 1 to 9 counts as a significant digit, right to the very end of the number. So in this case, we have 3 significant digits, or I would say SF, so significant figure is what I abbreviate it to, I guess. Zeros that are after a number are significant. So we will just start counting at the very beginning of our number. We see that we have a number from 1 to 9. So we count that one. That's a significant figure. This one's a significant figure. And once we start counting, we count to the very end of the number. So all of those values are important to remember. Therefore, in this case, we have 5 significant figures. Zeros within the number are significant as well. So once I start counting, because I've decided that it is significant, I will continue to count again, right to the very end of the number. So our first number here is 1, which is between 1 and 9. So we start counting our significant figures. So this one counts towards our total. So 1, 2, 3, 4, 5. Again, we just count right to the very end of a number once you start counting. All right. Base your significant digit or significant figure decisions off of measured quantities, not constants or whole values. So for instance, let's say I have a pen and it is 10.4 centimeters long. Now let's say I have 4 of those pens and I want to know how long does that make the trail of pens if I put them end to end. My value will be 41.6 centimeters, I do believe. Now, what this is trying to say is that we are going to count the significant digits in our measured quantity, so one that has a unit. There were 3 significant figures here. Because 4 is a counting number or a constant, we don't actually count it in significant digits. So when I'm looking for my answer, it should have 3 significant digits, again, because I've done multiplication. We're going to review that really quickly here. If I'm multiplying 2 measured numbers together, let's say I'm looking for the area of a piece of paper. A piece of paper is 8.5 by 11 inches. Let's say 11.0 inches, just to add a different number here. 8.5, sorry, these were inches. I should add units so we know what we're counting. This one has 2 significant figures. 11.0 has 3 significant figures because remember, once I start counting, I count to the very end of a number, including all of those last bit of zeros. So when I multiply this together, whatever you get, I don't have my calculator right in front of me. How many significant digits should our final answer have? Well, 2. We're going to follow those rules, which we are going to learn right now. Oh, just jokes. How many significant digits in these values? So let's take a quick look. We start counting right at the beginning of a number. 1, 2, 3, 4. Count to the very end. That's 4 significant figures. 1, 2, 3, 4, 5, 6, 7. And this one looks like scientific notation. I count the base number. I do not worry about the 10 or the exponent. So 1, 2, 3, 4 significant figures. I forgot one more type of example. So let's do 0.00000047162. 0. Let's add another 0. Why not? So remember, all of these are leading zeros. They do not count. I have to get to where we have a number between 1 and 9, and that's where I start counting. And then I count right to the end of the number. 1, 2, 3, 4, 5, 6 significant figures. Okay, here's where we start our rules for significant digits. For multiplication and division, The result should have as many significant figures as the measured number, so the one with a unit, with the smallest number of significant figures. So let's give these some units maybe. This was centimeters by centimeters. Our units should be centimeters squared in the end. Okay, so these are both measured numbers. Let's figure out how many significant digits each of them have. Starting here, 1, 2, 3, 4, 5 significant figures. And our second measured number has 1, 2, 3 significant figures. So I put this into my calculator, and this is the answer I get. This is my unrounded or my interim answer. Yes, it's the answer, but it doesn't correctly represent our values with significant digits. So what we need to think about is we're going to take the smallest number. So 3 significant figures is smaller than 5 significant figures. So that's what we need to round our final answer to. So that means I need to keep the first 3 numbers. Those are the most important. That means I'm going to cut off all of these. The only thing I need to consider is, do I need to round based on the number just outside my significant figures? And yes, I do. So I'm going to round to 276, and that would be centimeters squared for my final answer. Just circle your final answer so it's nice and easy for me to find. We do mostly multiplication and division in Chemistry 20, so this is the rule you would use the most. Addition and subtraction is still important, but we don't use it nearly as much. So for addition and subtraction, the result should have as many decimal places as the measured number with the smallest number of decimal places. Okay, so kind of my example here is we're measuring to the same amount of accuracy. If I asked you to measure a third of the way across the classroom, and I'm going to measure another third, and I'm going to set another student to measure the other third, and we don't talk about anything, we come back with our measurements. So let's say you measured your third of the classroom, and you got 6.2 meters. Your other student measured the other third of the classroom, and they got 7.432 meters. And I measured mine, and I was getting lazy and distracted, and I just said mine's 5 meters. Who was the most accurate? Probably this student. However, when we add up all of our results, we have to represent our number with the least amount of accuracy. Okay, so the smallest number of decimal places. Well, my answer was the smallest number of decimal places. So let's add these up. 6 and 7 is 13 plus 5 is 18.632 meters would be our final answer here. However, because I was being a little bit lazy, we don't get to keep any of these decimal places because my answer had no decimal places. Therefore, we're going to round to 19 meters. Now, if I'd been a little bit more accurate and added a 0, we could have said that this was 18.6 meters, but because I wasn't, 19 meters is our final answer. So the smallest number of decimal places, or the least accurate answer, or measured quantity, within our addition or subtraction statement is what we are going to record. Okay, so let's give these some units. Let's say this was centimeters again and centimeters. So we add our 7.435 centimeters to 2.85456, and we get 10.28956 centimeters. We need to decide who is the least accurate or the smallest number of decimal places. So this one had 3 decimal places, and this one had 5 decimal places. Therefore, my final answer gets to have 3 decimal places. So I get to keep these 3 numbers. All right. To decide, at my cutoff, I need to decide if I'm rounding up or not. And because this is a 5 right here, that's forcing it to round up. Now, a 9 rounds to 10. So this becomes a 0, and we add a 1 to this, becoming 90. All right, so 10.290 centimeters would be our final answer. Scientific notation. To convert to scientific notation, we need to decide whether we're going to move the decimal place to the left or to the right. If I have a number where I need to move the decimal place to the right, okay, we are going to move 1, 2, 3, 4, 5, 6. The decimal place must always be between the first and second numbers. So this is the general form for scientific notation, where this can be a positive number or it can be a negative number. And what this is saying is that the decimal place must be between the first and second number. Always. It doesn't matter. So I've moved my decimal place here 6 times so that 6 becomes my exponent. And I get 5.3 times 10 to the negative 6. And that's because I would need to divide this by 10 to the positive 6 to get the correct answer. Okay. Now over here, if I have 156,000, my decimal place is technically at the end of that last 0. To put this into scientific notation, we need to move it 1, 2, 3, 4, 5 times to put the decimal between the first and the second number. So my exponent is a 5, and I'm going to drop all of the zeros. 1.56 times 10 to the positive 5, because if I have 1.56, I need to multiply it by 1, 2, 3, 4, 5 to get my answer back. Okay, so if the decimal point had to move to the left, the exponent goes up and it is positive. If the decimal had to move to the right, the exponent goes down and it is negative. You can always check your answer by putting this value into your calculator and seeing if it'll spit this out. If it's a really big exponent, it may not work, but you can always double check. So write the following in scientific notation to 4 significant digits. In our first example here, this is a whole number. The decimal is after the 5. So I need to move the decimal between the 1 and the 3. That's a non-negotiable for scientific notation. So I need to move the decimal 1, 2, 3, 4, 5, 6, 7, 8 times. I'm just going to make a little note of that. 4 significant figures means that I need to keep these first 4 numbers. So I'm going to write mine as, we have to decide if we're rounding up or not, and we do need to round up in this case. The 9 becomes a 0 and we add a 1 here. So our final answer in scientific notation to 4 significant digits is 1.310 times 10 to the, this will be a positive 8 because it's a big number. All right, so again, I keep this 0 because I need 4 significant digits. My second example here, decimal place is here. I need to move it between the first and the second value in our actual number here. So 1, 2, 3, 4, 5, 6. I move the decimal place 6 times. Let's decide what number we're going to represent. We need to keep the first 4 numbers. So do I need to round up here? No, I do not. I get to keep this as 1.602 times 10 to the, now because we had to move our decimal to the right, this is a negative 6. All right, solve with the correct significant digits. Put this into your calculator and solve it. Now there is a little trick here. Some of you, if I'd asked for the answer, would tell me that it is 182772115.4, that's what your calculator gave you. Others will tell me it's 0.182772115. So which one is it? Well, I would ask you, how did you get your answer? And those of you that gave me this first value would have put this into your calculator as 1.70 times 10 to the hat 4 divided by 9.3012 times 10 to the hat 5. Others that got this second answer, so that's how you got this one, would have done brackets around this. 170 times 10 to the hat 4 divided by 9.3012 times 10 to the hat 5. 5, and they would have put brackets there. Others that got this answer would have done 1.70 E4 divided by 9.3012 E5. And we would have gotten the same answer. So who's correct? Well, sorry to say that this answer is incorrect. This is our correct answer. Now why? What happened? You just told your calculator, in this case, to multiply 1.7 by 10 to the power of 4. So your calculator, first off, said we need to, I'm going to write this one up here a little bit, what your calculator is getting. So you have 1.70, and your calculator's like, I need to do bed mass. Oopsie, bed mass. So there's no brackets, no worries. I'm just going to do my exponents. So I'm going to do times 10 to the 4, which is 1, 2, 3, 4. And divide by 9.3102 times, and then 10 to the 5. I'm going to expand that out. Sweet. I did my exponents. Division and multiplication, remember, your calculator's not going to do these in a specific order. Your calculator's like, if all that's left is division and multiplication, I'm just going to work from left to right. So I'm going to multiply 1.7 by this 10,000. That looks good. And then I'm going to divide that answer by 9.3102. Cool. And then I'm going to multiply that whole answer by 100,000. That's where the problem lies. Because you forgot to use brackets, your calculator did not know that these were actually meant to be one number, that this is scientific notation trying to describe one value. So you get the wrong answer. Because we've used brackets down in this second example of how to get it, we got the correct answer. We've used brackets. However, the best way to put things into your calculator is by using the E button. To get this, you'll put 1.70, and you'll say, if you have your TI calculator, second comma, and the comma is right above the 7. It's got 2 little E's in yellow above that button. When you do this, you're going to get an E in there, and the E actually represents 10 to the hat. And then you just need to put in the value of your exponent, whether that is a positive or a negative number. So you'll type 1.70 E, your exponent value here, and then you can just continue on. That E tells your calculator, hey, calculator, I mean that this is one value. This is one number. So it's really important to either use brackets or the E button. And I prefer the E button because it's less things that I have to type. Okay, in the very end, let's go back to this question and figure out how many significant digits we should report this final answer to. There are 3 significant figures in our first value, and there looks to be 5 significant figures here. So we need to report our first value here to 3 significant digits. Our final answer should be 0.183, rounding up from our 7. Now you can write this in scientific notation if you want, but you don't have to. So it's still correct if you write 1.83 times 10 to the negative 1. Either or is fine. Don't forget BEDMAS, order of operations still applies, and for each operation you need to carry the correct number of significant digits. We don't actually do this at all in Chem 20, so don't worry about it. There's some practice in your booklet, identifying number of significant digits, doing some calculation, and writing them in correct sig figs.